Hello students, here is the question. Here we need to find the position velocity and acceleration graphs of a particle moving with a constant acceleration, and these are the graphs in the options. So let us look. We have a constant acceleration, meaning A is a constant, K is a constant over here. We know A can be written as dv by dt, K, because we have t in the differential term, we use t over here. Let me just change the t that I wrote, so that's more like it. Dv can be written as k into dt. We won't be applying any limits. Let's say a is a constant, so dv is equal to k dt. Now v becomes k times dt, so v is a linear relation between linear relation equation. So we can be option A, option B, or option C, because the option for the acceleration is a constant for all these three, so we can be any of these, and V is equal to kt. So using that, we can write V as dx by dt to be equal to kt. Once we have this, we can write x to be equal to k t square by 2, correct? So once we have that, we have the relation between x and t to be of parabolic form, because the parabolic form for any graph is having this formula or this general representation, y square equal to 4x ax. Now we just represent y in the place of t over here. So once we have that, what we have is the parabolic forms, and the only ones that we get are in option A and C. The parabolic forms are in option A and C only. Now we need to know which one is the correct option. So let us look over here. We know acceleration is constant, A is constant, V is proportional to time straight line graph, and X is proportional to t square parabolic graph. And option C is incorrect, because over there we can see that A is a constant, so V is said to be a decreasing graph, and if V is a decreasing graph, meaning the slope of V and T is negative, and if we integrate V and T of a negative slope, we get a decreasing parabola. But in that case, it was different. It was having the same diagram as the option A had, like this. So option C is incorrect and option A is correct. Thank you.